What's up, Inspire Vision Calculus class? I wanted to make a test review for you guys. That way everybody can get a awesome grade this week. So it is time to learn some math. But I know what you're saying. This salad in the middle of the screen, that doesn't mean learn. That's because today we are playing a mystery game. And this is in honor of our class president, Brandon. Here's how the mystery game will work for our review. We have an empty salad bowl. Every time you get a question right before I do, we're going to put a piece of the salad in the salad bowl. Why a salad, you ask? That's because I asked Brandon what his favorite snack is. What does he dream to eat every night? What does he want to go home and what does he crave? He told me all he wants for Christmas is a salad. So a salad, we're going to make you, Brandon. We're going to make you a tasty treat. Here is our first question. We have 4 sine of x. So the first step, following the fundamental rule of calculus, is we're going to find the integral, plug in our b, which is the top of the integral, and subtract the integral plugging in our a. So if I take the integral of 4, I get 4x. If I take the integral of sine, I get negative cosine x, because the derivative of negative cosine x is sine of x. I don't need to worry about a plus c because this is a definite integral. Now I need to plug in 6 pi. And this is the first answer I need to get, and then I need to subtract, plugging in 4 times 3 pi. Okay, so 4 times 6 pi is 24 pi. Use your calculator to plug in cosine of 6 pi. Which is 1. So since it's negative cosine, I'm going to say minus 1. This is our first answer. Then I'm going to put in parentheses my second answer because I'm going to have to distribute this minus sign. 4 times 3 is 12 pi. Then negative cosine of 3 pi. I'm going to type that in my calculator. So cosine of 3 pi is negative 1, so it's minus negative 1, which really means plus 1. But then I need to distribute a negative sign to both the 12 and to the 1, so it becomes negative 12 pi minus 1. And then we have 24 pi minus 1. If I subtract both of these, 24 pi minus 12 pi, I get 12 pi minus 2. If you got that answer, let's start off our salad with some lettuce. So put some lettuce into your salad bowl. Okay, next question. Number 2. We have another definite integral, so we're going to follow the rule of the fundamental theorem of calculus, which is this. So the first thing we have to do is find the integral of 2x. So if we do the reverse power rule, we're going to get x squared. Our original coefficient is 2. So we set our power times, we're going to figure that out, equal to the original coefficient. So this 2 came from right here, this 2 came from right here, and that would be a 1. So all we have is x squared to begin our integral. Then we're going to want to move the exponent up, which means we have minus 5x to the negative 2. Following the reverse power rule, we're going to add 1 here, so it becomes x to the negative 1 power. and we're going to do -1 times our what we're going to find out equal to our original coefficient, which is -5. And that answer would be 5. So our integral for the second one is plus 5x to the -1 power. Now let's plug in what we have. So we're going to do 8 squared plus 5. This x to the -1, that means it's a fraction. So it's 5/8. This is our first set. This is our f of b. Then we're going to do our f of a, which is 5 squared plus 5 divided by 5, because it's 5x to the -1 power. So 8 squared is 64. This is 64 plus 5/8, so that's 64 and 5/8, minus 25 plus 1, so minus 26. So if I take 26 away from 64, I get 38 and 5/8. But let's pretend, let's say you wanted this as a decimal instead. You get 38.625. If you got that right, let's put some more lettuce. You gotta have a lot of green. I got your back, Brandon. You gotta have a lot of green in your salad bowl. Okay, next question. This one is pretty straightforward. I want to make sure everybody's comfortable with integrals before we start applying this concept next week to a little bit harder stuff. So congratulations, I'm going to throw some easy integrals into your test. All we have to do for each one of these is the reverse power rule. If I do the reverse power rule, then I'm going to add 1 to 5 plus, or to the 5th power. So that becomes x to the 6th power. Then I'm thinking 6, which is my exponent, times what is equal to my original coefficient, which is 5. So that's going to become, think about division, that's going to become 5/6. That's my first term. Do the same thing here, x to the 5th. So 5 times what equals 3, and that is 3/5. Here's my second integral term. And then I have, since it doesn't have a variable, I need to put an x with it. Now notice this is indefinite, so to finish this answer, I need to put plus c. If you got this right, let's give Brandon some cheese. However, this cheese is too big, so make sure you cut the cheese. Okay, next question. We have another definite integral. So we have 2 plus cosine x. Now, I'm not going to give you, I've decided that this test, I'm only going to give you sine and cosine as your trig identities. Next test, I want to focus more on trig identities, but this test I'm only going to focus on sine and cosine. So I'm just making sure you got the steps for doing integrals right. So this 2 becomes 2x. This cosine, the integral of cosine, is sine. Okay, now let's plug in, because we're doing the fundamental theorem of calculus, our b, which is our top. So we're going to do 2 times 7 pi plus sine 7 pi. Got to get this answer first, and then subtract 2 times 2 pi plus sine of 2 pi. Okay, 2 times 7 pi, that's 14 pi. sine of 7 pi gives me, in my calculator, it gives me negative 4e to negative 13. This right here is scientific notation. That means I'm supposed to multiply it by 10, that e stands for 10, to the negative 13 power. Negative 13 power means I move my decimal place over like this, for 13 times over to the left. So that means that this is just 0. Okay, so sine of 7 pi is just 0. Okay, now over here we have 4 pi, and we're going to subtract this, so I'm going to put this in parentheses, and then we're going to figure out what sine of 2 pi is, which gives me 0 in my calculator. So the only thing I have to worry about here is doing 14 pi minus 4 pi, and that gives me 10 pi. If you have this right, let's give Brandon some shredded cheese. Gotta have a lot of cheese. Next question. You haven't seen this for a couple weeks, so I want to make sure you get this right. In order to get this integral right, you need to FOIL first. So we have 72x squared minus 16x plus 54x minus 12. And we're taking the integral of this. We're going to do the reverse power rule for each term. And we're going to start with this one. So if I add 1 to x squared, I get x to the third. Now I think 3 times what is 72? To finish this, I need to do division. So that's going to be 24x to the third is my first term. My second one, I add 1 to this, and that becomes x squared because there's an invisible 1 as a power. So 2 times what is negative 16, and that gives me negative 8. Then I should have combined like terms. Sorry. Well, I'll do it on the next step. Then I add 1 to here. So 2 times what is 54? That's plus 27. And then we have negative 12 as my last term. Sorry. Since I didn't combine like terms first, need to combine like terms now to be 19. And your final answer is this. Got that right? Give Brandon some carrots. Carrots are good for the eyes, but of course Brandon already knows that. We know where he works. Next question. Okay, we have another definite integral. I'm going to give you probably 40% of your quiz and test to be definite integrals. So, fundamental theorem of calculus. And let's do it. You've reversed power rule for the 4x, so you're going to add 1, that becomes x squared. So 2 times what is 4 is the question you ask yourself, and that is a 2. First term is 2x squared. Here, since we have a fraction, we're going to move this up, and that becomes negative 3x to the negative 2 power. Add 1 to this, and that becomes x to the negative 1. So we have to ask ourselves, -1 times what is -3? And that would be a 3, positive 3. So it's going to be plus 3x to -1. Remember that this -1 means it's a fraction. So when I plug in my 6, this is going to be 6 squared, 2 times 6 squared plus 3 over 6. My second one is going to be 2 times 4 squared plus 3 over 4. Okay, 2 times 6 squared, that is 72. 3 divided by 6 is half. You could say that's 72.5 or a half. Then minus 4 squared times 2 is 32 plus 3/4 or 0.75. Okay, now if you leave your answers as a fraction, we actually have to borrow one from the 72, make that 71. But I don't care which way you do this. You can make it a decimal. Like if you're doing this by hand, as they don't care which way you put your answer on the AP test. So you can leave it as a decimal or a fraction. Your answer is 39.75. Okay, that question is worth some tomatoes. Brandon likes his tomatoes, cherry tomatoes especially. Next question. You haven't seen this question in a while, so I wanted to make sure you get this right. This time I have 2 variables, so we need to combine by multiply our exponents. So this radical, we can write the radical as a fraction. So we have y to the 5th times y 9 over 2. Now, the rule for multiplying exponents is these actually add. If you're doing this by hand, you want to think 9 divided by 2 goes in 4 times with a remainder of 1. So it's really 5 plus 4.5. Or if you want to be lazy, type that in your calculator, hit math, enter. Either way, 5 plus 4 is 9, and you have your half. Okay. So, we have the integral of y to the 9. I want to write it as a mixed number here. So, 2 times 9 is 18 plus 1 is 19 over 2. That will help us a whole lot more than writing it as 9.5. Okay, so 9.5 is the same thing as saying 19 divided by 2, which will help us a little bit more when we take the integral. Now, let's take the integral of this. So we're going to do the reverse power rule. So we're going to add 1 to this. Adding 1 to 19 over 2 is saying adding 2 over 2, which is going to give me y 21 over 2. But we can't forget about our coefficient. So 21 over 2 times what is 1, because my original problem started with 1 as a coefficient. And that would be 21 over 2, or sorry, 2 over 21. Because we want our fractions to reduce. So our final answer, we can say 2 over 21 y 21 over 2, or we can say 2 over 21. We can make that 21 over 2 make a little bit more sense. 2 goes in 21 10 times with a remainder of 1. So it's y 10 to the 1/2, because it's still a remainder. Or we can convert it into a radical, saying 2 over 21 y to the 10th power underneath the square root of y. Either one of these answers I will take. You get this right, you have some cucumbers in your salad. Next question. This time you have an e, so you have a definite integral with an e. The integral of e to the x is e to the x. So using the fundamental theorem of calculus, you want to plug in e to the 0 minus e to the -1 power. E to the 0, anything to the 0 power is still what? 1. And then e to the -1 power, this -1 means it's a fraction, which really means that you would put it in the denominator. So I'm going to say 1 minus, I would probably want to put it like this. 1 minus (1 over e). That takes care of the -1. I will take that, but if you want to combine this to be one fraction, that means we need the LCD, which means we could write this 1, the LCD would be e, so we need to multiply both the top and bottom by 1, and then we would have that. This is probably a little bit better, but if you wanted to say this, both of those tell me you know what you're doing. If you got this question right, let's put a chicken in the salad. But let's cook that chicken before we put it in the salad. Next question. We have an indefinite integral. So the first thing we want to do is convert our radicals to exponents. So we have 10x to the 1/2 power. Then we have, treat this as one coefficient, 1/9. If it's in the denominator, that makes it negative, so x to the -1/2 power. Then let's do the reverse power rule. So we're going to add 1 to the 1/2. That's the same thing as saying 2 over 2. So 1 plus 2, that gives me 3 over 2 for my exponent. We need to figure out the coefficient. So 3 over 2 times what is my original coefficient? That's the same thing as saying you can do 10 divided by 3/2 if you want to be lazy, or you could do this times 2 over 3. That's going to give me 20 over 3x to the 3/2 power as my first term. My second term, I need to add 1 to the -1/2. That's going to give me a positive 1/2. So positive 1/2 times what is my original coefficient of 1/9. And that means we're dividing by 1/2. So 1/9 divided by 1/2 is the same thing as saying 1/9 times 2 over 1, which is 2/9. So that's plus 2/9 x to the 1/2 power. Okay, this is right. However, you're going to see these fractions combined and written as one fraction together, which means you need your LCD, which is 9. So your first fraction gets multiplied by 3. 20 times 3 is 60. X to the 3 halves plus 2x to the 1 half all over 9. Finally, if you want to convert it back to a radical, this is going to be 60. 3 divided by 2 goes in once with a remainder of 1, so that's 1x on the outside, 1x left underneath the radical, plus 2 square root of x all over 9. So there's 3 different ways for me to show this answer. This first way, which is 20 over 3, x to the 3 halves power plus 2 ninths, x to the 1 half power. By the way, if you don't have a multiple choice question on the AP test, this is fine to leave your answer like this. But I went ahead and showed you 2 other ways to write your answer because these questions are more popular for multiple choice and we have to be able to match our answer to a multiple choice question. So this, if you got this right, let's give Brandon some bacon. He loves bacon. I forgot to give him bacon in his pre-cal class, so let's make sure we got him covered with bacon in this class. All right, next question. Now, I've decided, because integrals kind of get confusing, I want to make sure we remember just to find how to find the derivative. So here's your derivative question. And we have a fraction, so we could remember this rule, which is if the numerator is, see, there we go. That's only for integrals. That's for integrals. But anyways, before I even said that, it's a lot easier if you just combine, because we're only dividing by one thing in the denominator. Let's combine, move up the denominator into the numerator of both. We can do that because we're dividing by one term. So 2x to the third power divided by x squared just becomes 2x. Then negative 1, and then we have this in the bottom, becomes negative 1x to the negative 2 power. Okay, now we're going to do the power rule, which means we multiply by our power. So our first term, we're going to multiply our power times our coefficient, which is 2, and then we're going to subtract 1 from our exponent, which leaves me with just 2 for the first term. But then for the second term, if I multiply these two together, I get positive 2. Subtract 1, I get x to the negative 3 power. That's our derivative. If I wanted to write this as a fraction because it's a negative exponent, then it would be this. If I wanted to combine our fractions with the LCD, my LCD would be x to the third. So I need to multiply both the top and bottom by x to the third, which would be 2x to the third plus 2 all over x to the third. So this is my answer combined. This answer right here is the answer without them combined, and this answer right here with the negative exponent, except for you're never going to see it with negative exponent. You always want to move your negative exponent. If you got this right, you put some turkey into your salad. Okay, we only have 2 more questions. Here's the next question. So the first thing I want to do is convert the radicals into exponents. So we have 4x to the 1/2 power plus 1/2 x to negative 1/2 power. We want to do the reverse power rule, which means we're going to add 1 here, and that's going to become 3/2. So 3/2 times what is 4, which is going to be 8 over 3, because we're going to do 4 over 1 times 2 over 3, or divided by 3/2. Either way, we get 8 over 3x to 3/2 power. Now next, we're going to add 1 here, so that's x to the 1/2 power. 1/2 times what is my original coefficient, and that would be 1. So 1 plus 1/2. That is fine, but if I wanted to combine these together, my LCD would be 3. So this gets multiplied by 3. So that's going to be 8x to the 3/2 power plus 3x to the 1/2 power all over 3. And I'm running out of time to convert that into radical form. If you got that right, give Brandon some ranch. Finally, last question, find the derivative. Remember with this, to convert this into a radical. Oh, sorry, it's already radical. Convert the radical into an exponent, which means you're going to have 1 minus x to the 3rd to the 1/2 power. Now, this question, I know it's been a while, that's why I want to make sure I'm going to put at least one chain rule problem on your quiz tomorrow. You need to do chain rule, which means we find the derivative of the outside, and then we find the derivative of the inside, and we multiply them together. So the derivative of the outside is 1/2 1 minus x to the 3rd to the negative 1/2 power. Derivative of the inside is negative 3x squared. Okay, remember that this negative 1/2 means it's a fraction. So if I put all this together, the negative 3x squared would be in the numerator. The 2 is in the denominator, and this 1/2 means it's a radical, like this. If you got that right, I forgot to give croutons to Brandon, so give Brandon some croutons. Okay, we're out of time for today, but if you finish this review, you can use it on your quiz tomorrow. I'm going to be that nice to you. All right, I'll see you tomorrow.